Now we discuss some question on infinite series. Question number 4. Show that the series 1 by 2 plus 1 by 2 to the power 2 plus 1 by 2 to the power 3 and converges to 1. Solution. Let summation n is equal to 1 to infinity, an is equal to 1 by 2 plus 1 by 2 to the power 2 plus 1 by 2 to the power 3, continue like this, which is equal to summation n is equal to 1 to infinity 1 by 2 to the power n. Same, if Sn denote the sum of first n term of the series, then Sn can be written as a1 plus a2 up to an, where a1 is equal to first term 1 by 2 plus a2 is equal to 1 by 2 to the power 2 plus an is equal to 1 by 2 to the power n. Clearly that series is a GP series, and we know that sum of a n term of a GP series is equal to a into 1 minus r to the power n upon में 1 minus r. So here a is equal to 1 by 2, 1 minus r is equal to 1 by 2 to the power n upon 1 minus r is 1 minus r, which is equal to 1 by 2 minus 1 minus 1 by 2 to the power n. 1 minus 1 by 2 is equal to 1 by 2. That cancel out. Remaining term is that. And taking limit n goes to infinity on both sides, which is equal to limit n goes to infinity 1 minus 1 by 2 to the power n. Here 1 by 2 is less than 1, so its power infinity, that term goes to 0. So we have only 1 minus 0, which is equal to 1. So therefore sequence Sn converges to 1. Then by the definition of the convergence of a series, that series is also converges to 1. Next question goes to question number 5. Here, show that the series 1 plus 2 plus 3 plus n and so on diverges to infinity. To solve this, let summation n is equal to 1 to infinity, an is equal to 1 plus 2 plus 3 plus n and so on, which is equal to summation n is equal to 1 to infinity n. If Sn denote the sum of first n term of the series, then Sn can be written as a1 plus a2 plus an. Here a1 is equal to 1, a2 is equal to 2, and an is equal to n. That is the sum of n terms, which is equal to n into n plus 1 by 2. Now taking limit n goes to infinity on both sides, we have limit n goes to infinity Sn is equal to limit n goes to infinity here, which is equal to infinity. Therefore sequence of nth partial sum of the series diverges to infinity. So therefore by the definition of divergence of a series, summation n is equal to 1 to infinity, an is also diverges to infinity. Now next, question number 6. Show that the series 2 plus 2 to the power 2 plus 2 to the power 3 diverges to infinity. To solve this solution, let summation n is equal to 1 to infinity, an is equal to 2 plus 2 to the power 2 plus 2 to the power 3, continue like this, which is equal to summation n is equal to 1 to infinity to the power n. Same, if Sn denote the sum of first n term of the given series, then Sn can be written as a1 plus a2 plus a3 up to an, where a1 is equal to 2, a2 is equal to 2 to the power 2, a3 is equal to 2 to the power 3, and an is equal to 2 to the power n. Again it is a GP series, and we know that sum of n terms of a GP is equal to a into r to the power n minus 1 by r minus 1. Here a is equal to 2 and r is equal to 2 to the power n minus 1 by 2 minus 1, which is equal to 2 into 2 to the power n minus 1, which is equal to 2 to the power n plus 1 minus 2. Taking limit n goes to infinity on both sides, we have limit n goes to infinity, that term is greater than 1 and its power is infinity, so that term goes to infinity. Therefore the sequence of nth partial sum of the given series is diverges to infinity. Then by the definition of the divergence of a series, given series is also divergent series. Now we discuss question number 7. Now we discuss the question number 7. So that the series 3 minus 3 plus 3 minus 3 plus 3 oscillate series. So let summation n is equal to 1 to infinity, an is equal to 3 minus 3 plus 3 minus 3 plus 3. That can be written as summation n is equal to 1 to infinity minus 1 to the power n minus 1 by minus 1 to the power n minus 1 3. Same, if Sn denote the sum of first n term of the series summation n is equal to 1 to infinity an, then Sn can be written as a1 plus a2 up to an, where a1 is equal to 3, a2 is equal to minus 3, a3 is equal to 3, a4 is equal to minus 3, and continue like this, and an is equal to minus 1 to the power n minus 1 by 3. Then we see if n is even, then n is even. In that case, that sum is goes to 0, and we see that if n is odd number, when n is odd, then number of term is odd, then we see that the sum of that series is 3. So therefore limit n goes to infinity, Sn is equal to 0 if n is even, and 3 if n is odd. So from this we conclude that the sequence Sn, nth sequence of nth partial sum is oscillate by the definition that series is also oscillate. Now we discuss question number 8. Show that the series 1 plus 3 plus 5 plus 7 divergent series. To show the solution, let's summation n is equal to 1 to infinity, an is equal to 1 plus 3 plus 5 plus 7 up to and so on, which can be written as summation n is equal to 1 to infinity, and nth term of that sequence is that series is 2n minus 1. If Sn denote the sum of first n term of the given series, then Sn can be written as a1 plus a2 up to an, where a1 is equal to 1, a2 is equal to 3, and a3 is equal to 5, an is equal to 2n minus 1. It is a AP series, and we know that sum of n terms of an AP series is equal to n by 2 into 2a plus n minus 1 into mid d. Here n is equal to n by 2. Here total number of term is n by 2, 2 into a plus n minus 1 into mid d. After solving these, we have Sn is equal to n square. Now taking limit n goes to infinity on both sides, we have limit n goes to infinity, Sn is equal to limit n goes to infinity on an square is equal to infinite. So therefore sequence Sn is a divergent sequence, and by the definition of the divergence of a series, the given series is also a divergent series. Now we discuss the question number 9. Now we discuss question number 9. Show that the series summation n is equal to 1 to infinity 1 by root n plus 1 is a divergent series. To show this, let us consider summation n is equal to 1 to infinity, an is equal to summation n is equal to 1 to infinity 1 by root n plus 1. Here an is equal to that term. To solve this type of question, first we rationalize that term, and after rationalizing, after multiplying and dividing by that term, root n minus root n plus 1, root n minus root n plus 1, we have that term here is a plus b into a minus b, which is equal to a square minus b square, which is equal to root n minus root n plus 1, root n square, रूट से टू स्क्वेयर से रूट को कैंसिल कट कर देंगे, कैंसिल किया, n माइनस स्क्वेयर से स्क्वेयर रूट को कट किया, n plus 1. From this we obtained minus 1, taking minus common, and after that we have n is equal to root n plus 1 minus में root n. Putting n is equal to 1 to 3 up to n, we get a1 is equal to root 2 minus root 1, a2 is equal to, putting n is equal to 2 here, we have root 3 minus root 2, a3 is equal to, putting n is equal to 3 here, we have root 4 minus root 3, continue like this, we have an is equal to root n plus 1 minus में root n. Adding vertically we have a1 plus a2 plus a3 up to an, which is equal to, from this we see that root 2 minus root 2 cancel out, root 3 minus root 3 minus root 3 cancel out, continue like this. In this pattern we have only two terms, one is root n plus 1 and minus में root 1. If Sn denote the sum of first n term of that series, then Sn can be written as a1 plus a2 plus an, that is equal to, from here, that sum is equal to root n plus 1 minus में root 1. This implies Sn is equal to root n plus 1 minus में 1. Now taking limit n goes to infinity on both sides, we have limit n goes to infinity root n plus 1 minus 1, which is equal to infinity. Therefore the sequence Sn, nth sequence of nth partial sum, is a divergent sequence. By the definition of the divergence of a series, that series is also a divergent series. Thank you, students.